This video will show how your coursework was marked and will hopefully explain how the marks for individual questions were arrived at. If I identify specific issues which I think you should pay close attention to when revising, I will mention that in the video. Okay, in the first two questions, I mostly record the marks which have already been given by Jennifer. So for the first question, I'm going to check what's going on. Actually, yeah, you, strictly speaking, you didn't say what was the smallest m for which was good for all of them, but I think that, I mean, you've been, yeah, okay, so you say that the order is 7. Okay, strictly speaking, you had to say what was the m which works for all, and you didn't say that. Okay, well, I think that to deduct 5 marks for that is a bit too harsh, so I'm going to change that, and I think I am still going to give you 9 out of 10, because strictly speaking, you, instead of finding the order, a multiplicative order of each individual element, you had to specify the order which, I mean, the minimum m which works for all. And you should be well aware that in an commutative group, in an abelian group, if you found the order of each element, this does not necessarily mean that you indicated the order of the whole group. You need to take the, I would say, you need to take the least common multiple of the orders here. And question 2, let me see. Okay. And question 2. What you've got here is okay, yes, that's correct. And in question 2, I'm happy to record the full marks, 25 out of 25. Now, question 3. In question 3, you correctly read off the check matrix. You identify the dimension and the cardinality as far as I can see. The weight enumerator. Okay, so you basically explain in detail how you count the vectors of each weight inside the code Y, which is fine, and you do get that the weight enumerator of Y is square of the weight enumerator of Z. I mean, my only issue with that is that if you, because you identified the structure of Y correctly, i.e. you could use the fact that the first 3 symbols form a code vector of Z, as do the last 3 symbols, you didn't have to go through this very explicit process with numbers. So I, for the not most elegant solution, I just give it 12 marks. Okay, yes, and I can see the example of a code vector of Y here, which is fine. Okay, next. Okay, next, let's see. Okay, the sum of all code vectors of Y. Right. Okay, so if you have if you fix the first element of V, you've got 512 ways to choose the other 5 elements. Let me check this. Okay, obviously the last 3 elements are chosen in 8 squared way. It's 64, and then the second and the third symbol are chosen in just 8 ways. Yes, that's true. Yes. Okay, so actually, yeah, I like this approach. So you fix the first symbol and then it is repeated 512 times. Actually, yes, I'm happy with this solution, and I'm going to give 4 marks for this. Right, question 4. Linearity. So here, I'm afraid I don't understand how you can take a symbol from F8 and multiply it by a binary vector. So no, that's a mistake, and I'm going to only give you 2 marks out of 4 for this argument. Next. Okay, so you already explained how this code works, zbin, so I'm happy to give you marks for that, and you explain why there is at least as many non-zero symbols in cbin as in C. That's fine. And yes, I can see, okay, yes, I can see that you explained the bound of 3, but unfortunately the bound of 3 is not really the tightest bound, so the bound of 3 was only worth 5 marks out of 15. This is what I give you here for question 4D. Question 5. For a linear code, you need an integer dimension, and this is logarithm, it's not integer, so over F8 it does not realize, and you've got the 17 field of 17 elements, and you do give me a generator matrix. In fact, yes, actually, I'm happy with this answer, and I give you 4 marks.